In this video I will give an instruction about the perpendicular bisector of section 10.1. Let's start with a little bit of basic information. The difference between a line and a line segment. In the theory here we see two blue lines. The first one is a line, the second one is a line segment. A line, by definition, has no beginning or end, so it goes on infinitely. We could always make it longer. A line segment does have a begin and an end point, in this case A and B. It could well be the side of a triangle, a line segment. Now, if we look at the red lines, we see here a perpendicular line to line L. A perpendicular line makes a 90-degree angle. Here we also see a perpendicular line, but something else is going on with this perpendicular line. It's not just perpendicular, it also bisects line segment AB, and by that we mean that it passes through the middle of line segment AB. So that's what a perpendicular bisector is. One of the most important properties of a perpendicular bisector is that each point on the perpendicular bisector of line segment AB has an equal distance to A and to B. So if I pick a random point, for instance this one, on my perpendicular bisector, then I know that the distance from this point to A is the same as the distance from this point to B. Now, drawing a perpendicular bisector isn't too difficult. Let's use this example. We have a line segment AB, and if we want the perpendicular bisector, we could, of course, measure out where the middle is. That should be here. Make a little mark. And then use the built-in perpendicular line of our geotriangle to draw a perpendicular line through that point. Don't forget the symbols. One symbol to indicate that it's perpendicular and another symbol to indicate that both of the sides are the same length. Again, each point on this perpendicular bisector, for instance this one, has the same distance to A as it does to B. In mathematics, however, we don't really like to measure things. Remember how I measured out the middle? That's not really precise, so we could also construct a perpendicular bisector. And constructing is done with compasses. To begin, you choose a radius for your compasses. It doesn't really matter which radius you choose, as long as you choose a radius that is at least as large as half of our line segment. So this would be fine, this would be fine, but this would be too small. So just pick any radius. I'm going with this one, and when you do, don't touch it anymore because we need it to make two different arcs. Right, so what I do is I take my sharp edge and I start at one of the ends of my line segment, and I make two arcs, one up here and one down there. Then, without moving the radius, I put my sharp edge on the other end of my line segment, and again I make one arc here and one arc there, and do it so that you have 2 points of intersection. If I now draw a line through those 2 points of intersection, through this one and through this one, then I would get this line. And this line is the perpendicular bisector of line segment PQ. We can check it. It is indeed perpendicular because this is a 90-degree angle. And if I measure, it's exactly through the middle. Now, don't forget the symbols, perpendicular and equal lengths. Now, as you can see, there are arcs that kind of mess up my drawing, but you have to leave them there. You can erase the parts that you don't need, like this one and this one, but you always have to keep the points of intersection that you used visible. One more thing then. Here we see a triangle ABC, of which 2 of the 3 perpendicular bisectors have been drawn. This line is the perpendicular bisector of side BC, and this line is the perpendicular bisector of side AC. Please note that I use different symbols to indicate equal length because this is not the same length as this necessarily, so you have to use different symbols. Now, if I draw the third one, the third perpendicular bisector of side AB, will it or will it not pass through the same point, point M, where the other 2 perpendicular bisectors intersected? Let's have a look. We take out our compasses again, we set a radius, an arc up here, an arc down there, move over to the other end, an arc down here, and an arc down there. Let's use red. If I connect my 2 points of intersection with a line, you will see that it indeed passes through point M, the same point as where the first 2 perpendicular bisectors intersected. Don't forget to complete the drawing with the symbols, like this. Now, it looks like they all pass through the same point. In exercise 5, you are going to prove that this is indeed the case with all triangles and that it is not just an accident. Good luck!